Here, Maxim and I will discuss main ideas of MyStyle architecture. This discussion is a part of our survey paper, Deep Learning for Face Generation and Editing. To learn more, check the links in the description and visit our GitHub repository. Imagine that we have a low-resolution image of a face of a known person, and we want to reconstruct a high-resolution image of that face. Or we have a high-resolution image of a face of a known person, but a part of this face is occluded, and we want to reconstruct this face without this occlusion. Or, for example, we have an image of a face and we want to change one of the parameters, like pose or smile. MyStyle architecture uses StyleGAN generator as a backbone for demonstrated editing examples. However, the StyleGAN architecture has two problems that MyStyle is seeking to solve. In order to edit a portrait image using StyleGAN architecture, first we need to encode a given portrait image into a latent space of a StyleGAN generator, such that the input image is represented as a point in a 512-dimensional latent space of a StyleGAN 2 architecture. Then, in order to edit certain features of the output image, like pose or smile, we need to move this point in 512-dimensional latent space along a certain axis to achieve a desired editing result of a generated image. As a consequence of this editing procedure, we have the following two problems. First, the identity of a person in the portrait image can be lost during this inversion step. In this example, you can see the original image and example of the generated image after the inversion of the original image into the latent space. Although the original image and the generated image after the inversion step look similar, the identity of a person was lost in this inversion step. Similar for the super-resolution problem. Although the reconstructed image looks natural, but the identity of a person was lost. The same is relevant to the Inpainting problem. An approach to deal with this identity loss problem was previously proposed in this work, Pivotal Tuning for Latent-based Editing of Real Images. Simply put, the key idea is to fine-tune a pre-trained StyleGAN generator to a given real image. MyStyle architecture extends this pivotal tuning idea to fine-tune on hundreds of portrait images of the given person. Thus, it is possible to fine-tune a personalized StyleGAN generator that can be used for editing for that person. For example, super resolution, inpainting, or changing smile, pose, and so on. MyStyle architecture uses pixel loss and LPIPS loss for fine-tuning of the generator. It takes about 80 minutes to fine-tune a StyleGAN generator on 100 portrait image examples on a single GPU. The second idea of MyStyle is that each photo that was used for fine-tuning a StyleGAN generator can represent an anchor point in the latent space W of StyleGAN generator. And this set of anchors can create a personalized subspace of the StyleGAN generator that can be used for further editing for a given person. Maxim will cover this step in more detail.
In the second part of this method, we use this anchor space to get personalized results. This space was described by generalized barycentric coordinates. Let's look at the following visualization. Suppose we have 3 photo examples of a person encoded into anchors. Then any point inside this triangle can be described by the coefficients of a linear combination of these anchors. In the graph, the corresponding coefficients are marked on the triangle edges. If one moves the point inside the triangle, the sum of coefficients equals 1. As soon as one moves outside this area, the sum becomes greater than 1. Such property of generalized barycentric coordinates allows us to detect when a latent point is inside the convex region of known anchors in the latent space, and when a latent point is outside this region. Authors propose to collect about 100 anchor examples of known pictures of a person that form a personalized region in the latent space W of a StyleGAN generator. Let's let alpha be the space of generalized barycentric coefficients. Then any point inside this personalized region is described by a linear combination of anchor vectors in this alpha space of coefficients. Now let's use this alpha space to solve inpainting, super resolution, and semantic editing problems. For the inpainting problem, the approach translates a point from alpha space into W space of StyleGAN and generates a reconstruction of the original image. Using the fine-tuned, personalized generator obtained in the previous part, the approach starts optimization search with the gradients from the central point of this alpha space, which corresponds to a vector with equal coordinates. After applying the inpainting binary mask to the original and reconstructed images using LPIPs and L2 losses with gradient descent in alpha space. This keeps the gradient step within the boundaries of the personalized area, which allows us to get the desired personalized results after some optimization search steps. To solve the problem of super resolution, the same LPIPs and L2 are used, only the downscaling operation is applied to the images before application of these losses. For semantic editing task, it is necessary to preserve personality. Existing directions in the latent space are learned for the whole domain of faces and are not personalized. Because of this, some directions may lie outside the anchor space, and any small step in this direction will lead to degradation of the quality of the edited image. To solve this problem, we need to project the direction on the alpha space and perform editing in it. This operation will transform an infinite linear editing to one with endpoints. Even if the direction is in anchor space, this space can limit the movement of the latent point, resulting in poor editing quality. We can solve this problem by using the Beta-dilation parameter, which shows how far the latent code can go beyond the boundary of the anchor space. This makes it possible to get more editable images with an adjustable loss of personality.
This discussion is a part of our survey paper, Deep Learning for Face Generation and Editing. To learn more, check the links in the description and visit our GitHub repository.